Hey geometry students, today this is what we're going to be looking at, section 2.4, using postulates and diagrams. And some objectives are to illustrate and understand postulates about lines and planes. So we're going to be looking more at the point, line, plane postulates. In the chapter 1 we looked at 4 of them, and today we're going to look at quite a few more. And then to accurately interpret geometric diagrams. That is very important in what we're about to get into, which are called proofs. And to accurately interpret the diagram that you're given is going to help you a lot out whenever we get into proofs. And then this third objective that you see here, to use properties of special pairs of angles to find angle measurements, that we're going to actually see in the classwork that we do, not necessarily in this show that I have for you today. Okay, so here are 2 of our vocabulary words that we're going to be doing today, postulates and theorems, and I'm about to show you the definitions of those. Okay, here is what a postulate is. Postulates are statements in geometry that are so basic that they are assumed to be true without proof. And these postulates are sometimes called axioms in our book, so those 2 words are kind of interchangeable. And then theorems are statements that were once conjectures but have since been proven to be true based on postulates, definitions, properties, or previously proven conjectures. So theorems are some statements postulates and theorems are both statements, but theorems are more complex than a postulate, basically. So, and you'll see some postulates here in just a little bit. Okay, so here are the postulates I was talking about, point, line, plane postulates. We're going to go through each of these. Number 5, through any 2 points there exists exactly one line. What that means is, here we have a point, here we have another point. We can say there exists a line on those 2 points. And then 6, kind of the same thing. A line contains at least 2 points, which is true. A line that I just drew contains at least 2 points. Let's see, postulate number 7. If 2 lines intersect, their intersection is exactly 1 point. Okay, what this is if I have 2 intersecting lines, it's understood that where they intersect is a point. Doesn't have to be stated that there is a point, it's just understood. Okay? Where was I? Postulate 8. Through any 3 non-collinear points, there exists exactly 1 plane. So, no matter where you find 3 points, it creates a plane, okay? Same thing goes with postulate 9. It's kind of stating the same thing like 5 and 6 were. And then let's see, postulate 10. If 2 points lie in a plane, then the line containing them lies in a plane. Alright, so I'm going to draw a little bit of what this actually means too. Let me get this pen out. So we have a plane, okay, and in that plane are 2 points, just like that. If that plane has those 2 points, then in that plane exists a line containing those 2 points. Okay? That's all postulate 10 is saying. Now postulate 11. If 2 planes intersect, their intersection is a line. Well, we've kind of looked at that before in the previous chapter 2, but here we go. I'm going to draw it out for you. Okay, so there appears a rough sketch of 2 planes intersecting each other that I have right here. And it's saying if these 2 planes intersect each other, then they intersect each other at a line. And that is true. It's right there. They intersect each other at a line. So there are the point line plane postulates. That's hard to say fast. But here we go. Let's look at some diagrams too. Well, let's look at some examples first. I forgot about these examples. Okay, example 1 is just going back to those point line plane postulates. And it says through any 2 points there exists exactly one line. So this is just a pictorial representation of what this postulate is saying. So here we have 2 points A, B, and therefore a line AB exists too. Okay? Right, let's look at another example. Okay, in example 2, we are asked to state the postulate illustrated by the diagram. So we're going to go back to those point line plane postulates above on your handout there, and state which one goes along with these diagrams. So it said part A says we have if and then 2 intersecting lines, then those 2 intersecting lines with a point highlighted there. So I would say that is postulate number 7. It's trying to state if 2 lines intersect, then their intersection is exactly 1 point. Pretty sure that makes sense to everyone. So go ahead and write out that this one right here is postulate 7. And then part B, we have 2 planes intersecting. So if 2 planes intersect, then their intersection is a line. That is postulate number 11. Okay, so that's just looking at some diagrams and what they're illustrating, and understanding the point line plane postulates a little bit better too. Okay, we're going to be interpreting some a diagram here, and we're going to look at what we can assume and what we cannot assume about diagrams. And it says here, when you interpret a diagram, you can assume only information about size or measure if it is marked. So certain angles or certain segments within the drawing, they have to have those little tick marks or angle markings on it to be assumed that they are true. Say that I am wanting to know on this diagram whether or not, say, this angle right here, FHJ, is congruent to, say, EJD, this one right here. They may look congruent on the diagram, but they have to be marked with these little angle markings to be assumed that they are true. Okay, so we're going to go through some what we can and cannot assume true type stuff here in just a second. Can you erase that first? Alright, so let's get started. This same diagram, here's what you can assume to be true. All points shown are coplanar. Well, this is one plane being shown, and all the points are within that plane, which means that they are coplanar. So yes, all of the points are coplanar. And it says angle AHB, so AHB, this one right here, and then BHD, this one right here. It says these two are linear pairs. You can assume that they are linear pairs because remember, the definition for a linear pair is 2 adjacent angles and that add up to 180 degrees. So, well, or are supplementary. And this line right here, the HJ or HD or whatever line you want to call it there with the multiple letters that we have on that line, that is a straight angle, and straight angles are 180 degrees. And if we have a line intersecting a straight angle, those angles that they create, the adjacent angles, are linear pairs. So we can assume that these are linear pairs in this one. Okay, let's look at the next one. It says AHF, this angle right here, and BHD right here, says are vertical angles, which is true. By definition of vertical angles, these two angles are vertical angles. Also, this angle, HJE, that, and CJD, those are vertical angles too. And there's a couple other pairs of vertical angles on this drawing. So if it meets the definition of a type of angle, like linear pair or vertical angles, then we can assume that much information is true. Okay, let's look at the next one. Collinear, let's see. A, H, J, and D are collinear. Well, we have, A, H, J, and D. All of those are on the same line, so they're collinear. And then let's see the next one, line AD. So, okay, this line right here, AD, and BF intersect at H. Well, that's true. That intersection right there is named H, and that's where they intersect. So these are some things, or some examples of what you can assume true. Now let's look at some things that you cannot assume to be true in a diagram. Okay, it says G, F, and E are collinear. Well, we have points G, F, and E, and we cannot assume that these 3 points are collinear, even though they may look like they're collinear. But what needs to be shown that they are collinear is that a straight line, is drawn through them. And then you can assume it's collinear. But as of the drawing, without the line through those 3 points, you cannot assume that they're collinear. Alright, the next one, line BF and CE intersect. So let's see. These two, BF and CE, intersect. We cannot assume that they intersect or will not intersect according to the next one right here. Meaning, well, we can't assume that they're parallel or not parallel. One can be slightly angled off just a little bit, and then way down here they actually end up intersecting each other. And then you can't assume that they will never intersect each other either. Just because of the drawing that we have here, we can't assume those two things. Okay, let's look at the next one. Angle BHA and CJA are congruent. So let's look at those. BHA right here and CJA right here. We cannot assume those two angles are congruent because they do not have the angle markings like I just drew on here. If they did, we could assume that they're congruent. Last one here. Line AD is perpendicular. That's what that upside down T means, is perpendicular. So line AD is perpendicular to BF. So here's AD, perpendicular to BF. In order to know to assume that that is true, then this must be a 90-degree angle and it must be marked like this. it should have a marking on it like that to know that that is a perpendicular intersection there or a 90-degree angle. All right, so those are some things that we can and cannot assume to be true about a diagram. Let's go on to the next slide. Okay, so here's another definition. A line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So, the line intersecting the plane must be perpendicular to that plane and all the lines within it. Okay, that's a pretty straightforward definition. Okay, last example I have here, we're just going to find which one of these statements we cannot or we can assume to be true from this given diagram. Okay, so let's look at this. We have one here we're going to look at. A, B, and F are collinear. Let's see, A, B, and F. Can we assume that A, B, and F are collinear? Well, they lie on the same line, so yes. I'm just going to write it out here. Say yes, that is true. And then let's look at the next one. E, B, and D are collinear. Where is E? E, B, and D. Well, remember, like I said, it does not have a line being drawn through those 3 points, so we cannot say that these 3 points are collinear. So let's put a no outside there. Now, number 3, AB is perpendicular to plane S. So AB, this line right here, is perpendicular to plane S. And here's the plane S, the orange plane. Okay, so we do have a little symbol right here showing that this line right here is perpendicular to this plane. So yes, this can be assumed true. Now let's look at the next one. CD is perpendicular to plane T. Okay, let's see, CD. This line right here, it's saying that this line here is perpendicular to this blue plane T. Well, if we had a little right angle symbol like this right here to show that it was perpendicular, then we could say that it's perpendicular, but we cannot. So let's say no here. Last one, 5. Here we got AF intersects BC at point B. So where's AF? AF. So AF intersects BC at point B. That is true. Those two lines do intersect at point B. So say yes. All right, well, I hope you learned just a little bit about diagrams today in this lesson. And that's all I have for you. Everyone have a good night, and I'll see you in class.